Okay, folks, let's talk a little bit more about proving triangles. Now, we have already talked about taking triangles like this and trying to figure out what do I know, what do I have, what can I get. Things like vertical angles or reflexive sides to get triangles congruent and prove them congruent by side, 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 angle, side, angle, angle, side, or hypotenuse leg. But now, let's go to the next level. Once the triangles are congruent, the whole point is that every part of that triangle is going to be congruent to each corresponding part in the other triangle. Now, here's what I mean by corresponding parts. Corresponding parts means this side right down here goes with this side right here because it's short-sided triangle, short-sided triangle. This angle here would correspond to this angle here because they're over here at the edges of the triangle. This angle here would correspond to this angle here. And we have a phrase called corresponding parts of congruent triangles are congruent, which means if I can get the left half congruent to the right half, that means all the parts on the left and all the parts on the right are congruent to each other. So instead of proving all 6 pieces, let's just get enough to prove the triangle's congruent. With that in mind, we know that CDB is a right angle. Now, what do we know about right angles? Well, right angles equal 90 degrees. So angle CDB equals 90 degrees by definition of, well, what did we just say it was? We said it's a right angle. That's why. So it's of right angle. Now, that's great. The other thing is we say, well, that means this one over here is right. Well, yes, it is. That's true. But guys, in a proof, we have to prove it. So how in the world are we going to prove that this angle here is a right angle? What we're going to have to do is the same old proof that we've done before and say this angle plus this angle equals 180. So angle CDB plus angle ADB equals 180 degrees by, well, there are 2 angles next to each other that make a straight line, so that would be by linear pair. Now, since we know that CDB equals 90 degrees, I can put it right there and say 90 plus angle ADB equals 180 by, well, I took something out, put something in, substitution. All right, now we can finish getting this angle by itself, saying minus 90 angle ADB equals 90 degrees by subtraction. All right, now that's good. You say, great, now the 2 angles are congruent. No, they're not. They're not congruent yet because you haven't said they are. So we're going to actually have to say that angle ADB is congruent to angle CDB. You say, but why do I have to say it? Well, because that's the whole point of a proof, guys. We can't say something is true unless we can give a reason, and we can't make a statement without a reason. In this case, ADB equals 90, but we already knew that CDB equals 90. So instead of putting 90 here, let's replace it with CDB. And so by substitution, we know that those 2 angles are congruent. You say, great. Those triangles are both 90 and they're both congruent. Well, yes, they are. And now, if we put it together with the fact that we know that angle AD or side AD is congruent to side DC, AD to DC, because that's a given right from the top, we're really close. We have one set of sides, one set of angles in each triangle. Now we just need to find another piece. Well, what's the other side that's available using reflexive property? Well, BD is congruent to BD by reflexive. And with that in mind, we now have a side, an angle, and a side, an angle, and a side. So that allows us to say triangle ADB is congruent to triangle CDB by side, angle, side. Side, angle, side. Now you say, great, yay, we proved the triangles, but that's not what we're trying to prove. We're trying to prove A is congruent to C. This is where corresponding parts of congruent triangles are congruent come in. Now that these two triangles are congruent, that means each corresponding piece of this triangle are going to be congruent to each other. So we could say BC is congruent to BA by cpctc. We can also now say this angle up here is congruent to this angle here by cpctc. But what we're interested in is saying angle A is congruent to angle C because they are corresponding parts of congruent triangles. So by cpctc, we now know that these two angles are congruent. So in this case, we had to prove an angle. So we had here to prove an angle. Then we had to prove the triangle. And finally, at the last piece, we proved parts. Now, by the way, this is just the start, because now that I know parts are congruent, now I can also say other things about this triangle. Because if I have this angle is congruent to this angle, that means what is true about this big triangle? Well, what you could say is you could say that triangle ABC, so let's just put it right up here. Triangle ABC is isosceles. We could say it's isosceles because base angles theorem. Base angles theorem. Now you say, well, but I thought isosceles meant two congruent sides. Well, it does. But if we have these two angles are congruent, then what's true about those opposite sides? They're congruent. And if they're congruent, then we can say that the triangle's isosceles. But if you don't like it, you could also have said that AB is congruent to BC by cpctc, and then you could say that is isosceles by definition of isosceles. So in this case, what I want you to get is that you can prove different components, and you'll have little sub-proofs even within one proof, and all of the things that you should have learned already are going to come back into play. So that's the first one for today.